Hello everyone, in this video we are going to see about the ensemble learning. Ensemble refers to the combination of several distinct set of individual machine learning techniques together to enhance the strength, efficiency and predictive performance of the model. The ensemble learning has three major techniques: bagging, boosting and stacking. Bagging or bootstrap aggregation builds several instances of the models based on random subsets of the original training dataset and then aggregate their individual predictions to form a final prediction. Here, the training data will be splitted into various subsamples and each subsample will be given to a learning algorithm to learn the pattern and build a classifier. Based upon the each sample, the learning algorithm builds a classifier which are then combined by using either aggregation or majority voting to form a final prediction. The steps in bagging are: it assumes that there are n observations and m features in the training set. Select a random sample from the training set without replacement. A subset of m features is chosen randomly to create a model using sample observations. The feature offering the best split out of the lot is used to split the nodes. The tree is grown to have the best root nodes. The above steps are repeated n times. It aggregates the output of individual decision trees to give the best prediction. The advantages of bagging are: it minimizes overfitting of the data, it improves model accuracy, it deals with higher dimensional data efficiently. The disadvantages of bagging are: it introduces a loss of interpretability of a model. Resultant model can expertise lots of bias when the proper procedure is ignored. It can be computationally expensive, which may discourage its use in certain instances. Boosting is a set of algorithm which converts weak learners into strong learners. It is an ensemble learning technique that uses a set of machine learning algorithms to convert weak learner to strong learner to increase the accuracy of the model. So initially, a subset of the training data will be given to first algorithm, where the algorithm learns the pattern and it predicts based upon the performance. Then the next algorithm will be trained using the training data set, where the samples which produces high error will be given high weightage. So similar to that, it will be processed sequentially. It cannot be processed parallel. In bootstrap aggregation, we can learn multiple algorithms in a parallel fashion, whereas in boosting we can process only sequential processing. The steps in boosting are: boosting algorithm assigns equal weight to each data sample. It inputs the data to first base algorithm and predictions are made for each sample. The boosting algorithm assesses model predictions and increases the weight of samples with a more significant error. It also assigns a weight based on model performance. A model that outputs excellent predictions will have a high amount of influence over the final decision. The algorithm passes the weighted data to the next decision tree. The algorithm repeats step 2 and 3 until instances of training errors are within acceptable limit. Types of boosting algorithm. Adaptive boosting. Adaptive boosting uses the same training dataset over and over and thus need not be large, but the classifier should be simple so that they do not overfit. AdaBoost can be used for both classification and regression based problems. However, it is more commonly used for classification process. Gradient boosting. In gradient boosting, the base learners are generated sequentially in such a way that the present base learner is always more effective than the previous one. That is, the overall model improves sequentially with each iteration. Extreme gradient boosting is an advanced version of gradient boosting method to increase the speed and efficiency of computation. The advantages of boosting are ease of implementation, reduction of bias, computational efficiency, etc. And the challenges are vulnerability to outlier data, real-time implementation, difficulty in real-time implementation. Stacking. Stacked generalization is a technique which extends voting in the way that the output of the base learners is combined. They need not be linear, but it is learned through a combiner system, which is another learner whose parameters are also trained. The training data will be given to classifier, which is used to make some predictions, and based on the output value, a new classifier will be trained and it performs the prediction. In stacked generalization, the base learners can be as different as possible so that they will complement each other. Whereas in bagging, we are going to use either the same algorithm will be trained with different type of data set, but in stacking we are going to use different algorithms for each training data set. Combining classifiers that can generate continuous outputs is better. Bagging. Bagging reduces variance and increases accuracy, whereas boosting reduces bias and increases accuracy. Stacking reduces both bias and variance. Bagging is robust to outliers. Boosting, it is not robust to outliers. In bagging, random resampling with replacement is possible, whereas in boosting, stepwise misclassification based decorrelation is possible. In stacking, training second level machine learning algorithm to learn optimal combination of base learners is done. In bagging, homogeneous uncorrelated learners are used. In boosting, homogeneous weak learners are used. And in stacking, weighted majority voting is executed. The aggregation of results is through voting or averaging in bagging. Aggregation is through weighted majority voting in boosting, and meta learners are used for combining the results.